All right, so yesterday we talked about writing proofs some more using geometric relationships. Today we're going to build on that. So right now what I would recommend doing is pausing your video and trying to match all of these to the correct spots, and this is just a flow chart. All right, once you've unpaused, hopefully you notice that this is given, so E. This one here is the angle addition postulate because angle 1 and angle 2 make up angle EBA. This is the substitution property because you're using the first two pieces and putting them together. This here is F, which is the commutative property, so we're rearranging the order of 1 and 2. This one here is also the angle addition postulate, so you could actually switch around A and D. Okay, and then this last one here is the transitive property because you're cutting out, remember, this entire side of the equation and this entire side and setting these two pieces equal to each other. Okay, so I'm going to show you a new theorem, and that theorem is that it's the right angles congruence theorem, and that just says that all right angles are congruent, something we would assume, but it does have a name. Okay. So now we're going to use that idea and we're going to write a proof. So here's the flow chart, and really what we're going to do is we're going to take the flow chart and we are just going to turn it into a 2-column proof. Okay, so here's the flow chart proof. So the first thing I'm going to do is I'm going to write the statement, which is angle 1 and angle 2 are right angles. And then the reason here is given. And so really each of these is just going to be one statement. And then the measure of angle 1 equals 90 degrees, and the measure of angle 2 is equal to 90 degrees. And that is because of the definition of a right angle. Okay. And then we have 3 here, so let's go back up a little bit so we can see, and that's going to be the measure of angle 1 is equal to the measure of angle 2. And that's the transitive property. Okay, and that's because we took these two from number 2 and took out the 90 and set them equal to each other. And then the last statement here is angle 1 is congruent to angle 2, and that is because the definition of congruent angles. Sorry, I'm running out of room. Okay, a couple of things is number 2 could be separated into 2 separate statements. You could do one for each of these. That's probably actually what I would do if I had more room. And then also the congruent angles, that goes back to this, that all right angles are congruent. And so since these are both 90 degrees and they're equal, that's going to be congruent angles. Okay. All right. So here's a couple more theorems. The first one is that congruence supplements theorem, and all that this theorem is saying is that if 2 angles are supplementary to the same angle, then they're equal. So for example, if angle 1 is supplementary to angle 2 and angle 3 is supplementary to angle 2, then angle 1 and angle 3 are equal. Okay, the same thing goes for the congruent complements. If there's 2 angles that are complementary to the same angle, then they're equal. They're congruent. Okay. So like 4 is complementary to 5 and 6 is complementary to 5, then we know 4 and 6 are equal to each other. Okay, I would again pause this and see what you can fill in, and I'm going to go through it, but if you want to pause it right now and then just fill in what you can and then come back and we will fill it all in together. Okay, so we know that angle 1 and 2 and 3 and 2 are supplementary. So we also know that angle 1, the measure of angle 1 plus the measure of angle 2 is going to be equal to 180 degrees, as well as the measure of angle 3 and the measure of angle 2, and that's the definition of supplementary. Okay, that's what it means, is that they are 180 degrees when you add them together. Okay, then we're going to take out these 180s and we're going to say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2, and that is the transitive property. Then we're going to come down here, take away measure of angle 2 from both sides, and get that the measure of angle 1 is equal to the measure of angle 3. Okay, and that's the subtraction property of equality. Okay, and then from there we know that angle 1 is congruent to or the same shape as angle 3. And that's the definition of congruent angles. And so what we've just done is proved the theorem from the previous slide. We've proved that two angles that are supplementary to the same angle, like these are actually congruent. Okay? All right, linear pair postulate just says that linear pairs are supplementary, which we've actually talked about. And then vertical angles congruence theorem, that actually says that vertical angles are congruent, which we've also talked about. So those are just review. Okay, now I would like you to pause this and try and write a 2-column proof. I will say that my proof has 5 steps in it, 5 statements and 5 reasons. So pause and try and write a proof with 5 statements and 5 reasons. Okay, now that you have paused and you've come back, this is what my proof looks like. See if you agree. So first is always going to be our given. So angle 1, that's a 1, and angle 2 are complementary. Okay, so that's the first given. And I separated my 2 givens, and so this is the second one. Angle 1 is equal to 37 degrees, also given. Okay, and I said that mine's going to have 5 steps. So 3, 4, and 5. And I know that this is what I'm trying to prove. Angle 2 is equal to 53 degrees. So I'm going to try and fill those in first and then do my reasons. So I know that 1 and 2 are complementary, so I can use that to then write an equation. So angle 1 plus the measure of angle 2, measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. And that's because that's the definition of complementary. They equal 90 degrees when you add them together. Okay. And then statement 4, I'm going to do some substitution with 2 and 3. So I know that angle 1 is 37, so I'm going to put that in here. I'm going to say 37 plus the measure of angle 2 is equal to 90. And that is substitution. Sorry, that's number 4, not number 5. My handwriting is bad today. Okay, and then number 5, that's going to be, we're going to take away 37 from both sides and use the subtraction property of equality to get that proved statement of angle 2 being equal to 53 degrees. Okay? All right, let's do another one. So here, this is new. We haven't seen one with a diagram before. So I'm going to write a couple statements that we know. And so the first one that we know is angle QPR is equal to 3x plus 1. And so our reason for that is going to be the diagram. So it's like having a given, but it's in the diagram. We also know that angle TPS is equal to 148 degrees, also in the diagram. have number 3, and what we want to do is we want to find the value of x. That's going to be our last statement, is finding that value of x. So what we can do is then look at this and see what else we can deduce from the diagram, and we can say that angle QPR, QPR is equal to or congruent to angle TPS, and that is because they are vertical angles, and vertical angles are congruent. And if we know that they're congruent, we can substitute in these values here that we know. So this is substitution. And then we can subtract 1 from both sides, which is the subtraction property of equality. And the last thing we're going to do to get what x is divide by 3. So x equals 49, and that's the division property of equality. Now, the last thing we're going to do is we're just going to look at some diagrams and solve for some vertical angles. Okay, so we're not actually going to do some proofs here. We're just going to use the vertical angle congruence theorem. So what we know is vertical angles are congruent. So we have 2 separate ones. We have this first one here, this set with the 4x equals 6x minus 26. We also have another set, 7y minus 12 equals 6y plus 8. And we know we can set those equations up and have both of those be equal to each other because we know that all vertical angles are congruent. Okay, so remember they share a vertex and they're formed by the same 2 lines and they're across from each other. So then we can go ahead and solve this. I'm going to start with this one here and subtract 6x from both sides and get that negative 2x equals negative 26. Divide both sides by negative 2 and get x is 13. Okay. Then we're going to do the same thing over here. I'm going to subtract 6y from both sides and I get y minus 12 equals 8. And then I can add 12 to both sides and get y is equal to 20. And I just realized on the one that I uploaded, it says 22. Apparently I was tired. Anyways, so we've solved for x and y, and this is again using the fact that they are vertical angles, okay? And vertical angles are congruent, and we're going to use that a lot in our proofs, okay? Please let me know if you have questions. You're going to have questions like the proofs and like this on your homework. So if you have questions, let me know. Otherwise, go ahead and do this 2.6 Big Ideas assignment. Please email me with any and all questions or write them down and I can go over them at the beginning of class tomorrow. You can also start on your test review. I have posted that in Google Classroom as well, and so you can start your test review so that you can get questions answered tomorrow, and your test will be the next day.